Howdy. Hello fellow engineers, today I'm going to do an analysis on the Class A amplifier. So first, when we get this Class A amplifier, we will be connecting the input to the channel 1. But at first we do not need this input, as we are going to measure the beta first. So we are going to unplug this. Most importantly, we have to connect this power source to the DC power supply to the circuit, and now it's already connected. So I just have to switch on the output so that the power supply will be supplying the circuit. So first of all, we are going to find the beta DC of the transistor, and this can be done by measuring the VC. So to measure the VC, we need to use a multimeter across VC, and the value we got is 5.586 volt, which is roughly very close to the one we found. So now we're going to measure VD1. So in order to measure VD1, we have to turn the switch 2 off. So when it's off, I need to push to the 2. So once it's off, I need to measure across VD and the ground. So the voltage I got is 1.5730 volt. And following, I'm going to measure VD2. To measure VD2, I have to switch on the switch 2. And once I switch on the VD2, the value I got is 1.5785 volt. And now we can make use of the two difference value to find the RTH. And which is a principle involved behind is VP1 minus VP2 is IB times RTH. And IB we have found in the before. And now I'm going to verify the mid-frequency gain. And in order to verify the mid-frequency gain, we have to make use of the function generator and the oscilloscopes to view the graph and the waveform. So we have to connect the cables, the channel 1, to the circuit, the input of the circuit. Make sure it's tight enough. Then we also have to visual the input waveform, and we have to connect the crocodile pin to the input into the ground, and then to the channel 1 of the oscilloscope, which is here. Then we also have to visualize the output of the waveform, and we connect a second cable of the channel 2 of the oscilloscope to the output of the circuit. So the output is over here in the ground. Okay. And now we are going to set the function generator to 10 millivolt P2P, and then the frequency to 10 kHz. After that, when this is done, we have to output the signal by pressing this. And now we have to look at the oscilloscope, and it doesn't show anything. We have to press the auto set. Okay, so now we have the sine wave in the screen. So we might need to adjust them inside this box within the range, and we press measure. Once we press measure, we have to look at the input of the VP2P and output of the VP2P, and we can find the frequency gain by using V out over V in. And it's 12.6 millivolt and 1.6 volt, and we can press our calculator. So after the overall of the division, right, 1.5 volt divided by 12.8 millivolt, and is the frequency gain is around 132. Okay, now we have to determine the resistance of R in and the R out. Now I will turn the R in fully counterclockwise. And the switch is switched off, which is at position 1. And then now I will switch on this switch and adjust this 2 volt to half to 1 volt, which is 50% of this. So by adjusting the R in, we were able to get the value to half of the 2 volt. Yeah. Now we roughly get 1 volt, 1.03 volt, which is very close. After adjusting them to 1 volt, so I have to switch off this and measure the resistance of the port 2 of R in. And the resistance we roughly get is 1.2251 kilo ohm. And now we are going to do the same to the resistance output for this circuit. And now we're going to switch this switch to switch 1 and fully clockwise the variable resistor. And then we will switch this switch to switch 2. And I'm going to adjust this value to 50% of the 1 volt, which is 500 millivolt. I'm going to turn counterclockwise to adjust the oscilloscope value to 500 millivolt. Now I've got a pretty near value of 504 millivolt, and now I'm going to switch the switch back to switch 1, which is off. I'm going to measure the resistance across, and the value I got is 5.052 kilo ohm, so it's around 5 kilo ohms. Okay, so now we will set the function generator's frequency to 190 Hz. And now we will verify the knob and adjust the knob until the voltage output gets to 1.44 volt, which is 70.7% of the 2 volt. Now I will start adjusting. And the V out gets decreased slowly until it reach 1.44 volt. Yeah, and now we roughly get 1.44 volt. And we record down the frequency, which gets it to 1.44 volt, which is 52 Hz. Okay, so after finding the FCL, now we're going to find the FCU. So we adjust the function generator's frequency to 100 kHz, and this will be the same procedure as just now. And now I'm going to press measure. I'm going to adjust the knob. And slowly let the output voltage to 1.44. Yeah, and now we're going to record down the frequency that makes it 1.44 volt, which is 270 kHz. And this is the FCU. No, sorry, this is the FCU.